Okay. I guess we'll get started here. Welcome to Common Lisp Study Group. Today we're going to talk about anaphoric macros. But before we do that, there's two topics that are kind of remaining from Chapter 5 that kind of lead into the anaphoric discussion that I wanted to at least bring up, at least from my reading of the book. And trust me, I've been going through this and on Lisp kind of to wrap my head around this. Still not entirely convinced I understand it. I'm hoping we can have some really good discussions on some of the examples that I'm going to be showing. The first thing to talk about is Macrolet, which is a way of doing code walking in Common Lisp without writing your own code walker, or at least that's what the book describes it as. I'm not entirely sure that's an accurate description, but of course I'll leave that to the experts that are in this panel. The other one was an example that he gave, kind of an extension to closure-oriented programming to allow you to write multiple methods inside of a closure and figure out a way of calling multiple methods on a closure using a simple, I guess I would call it a trick, but we'll get to that. It's called Lambda in the book, called dispatching Lambda. Allows you to pass in a method that a keyword symbol to a closure, and based on what keyword symbols pass, the particular function will get invoked. And then we'll lead into our detailed discussion of anaphoric macros. What we will not be covering today, I'll try to get to it, but I'm pretty sure we won't be able to cover today, is Pandoric macros. But if we do, it'll be a surprise for folks who are,
Yeah, that's quite a large topic.
Yeah.
And we definitely need to cover anaphoric macros to get there.
Right.
Yeah, Pandoric macros may be a bit of a stretch.
But, we'll see how far we get. Apologies. My apologies. My phone was right behind my computer, so my apologies for folks. So let's get started here. The first thing that we're going to be talking about is Macrolet. Now, I'm pretty sure the majority of folks that are on this panel know kind of what Macrolet is, but I'll just go through it anyway. The book describes it basically as a way of not having to write your own code walker, because what Macrolet allows you to do is it allows you to define a function, define a macro that can be expanded within a particular lexical context. And the example that it uses to do this, which I have shown here in my Emacs buffer, is implementing a tail recursive version of nlet without having to actually expect the common Lisp implementation to actually have tail call optimization. Again, I'm not entirely sure if this actually will work in those situations. I've tried it on SBCL, but SBCL, as many of you know, already does.
Yeah, so actually, the nlet tail macro, or some version of it, is actually present in Serapium. It's a pretty standard macro. It is, however, kind of weird, because it's really easy to use it improperly and get yourself into weird situations if you're not really careful to make sure you're actually doing tail calls.
Yeah, and I think we should talk about that a little bit, because how the expansion works is I think kind of I'm still going through this, and I'm not entirely understanding this. If you're first, I'm assuming you guys can see my Emacs buffer. Is it?
Yeah.
Okay, cool. So line 134, 131 through 134, where we're actually defining the macrolet. This p set q, I haven't seen it up until now. I've never used it up until now.
Like cubic parallel.
Oh, just parallel? Okay.
Yep. It evaluates all of the right hand sides before it assigns anything to the left hand side.
Okay. Alright. So it basically breaks it down so that we have all the evaluated forms before we actually do the assignment. Okay, that makes sense.
Right.
Okay.
I would use psetf.
You use psetf?
Yeah.
Okay.
It's like psetq, but it's set up instead.
Right. That brings up an interesting thing that
there's not much point to use set q over pset, set q over set f anywhere. I mean, in rare circumstances.
There's no point to ever using set q over set f.
Yeah, on Lisp actually convinced me that that's the case. It's just that I got this straight out of course I got when I read Let over Lambda, he does a lot of things that I'm just like, okay, there must have been a reason that he did this, but I haven't actually, tried to go and, experiment and say, oh, well, technically, according to On Lisp, you shouldn't be using this anyway, This,
Plus, it kind of helps to, if we're going to talk about the book, we might as well at least start with what the book actually says.
Yeah.
Right.
Exactly.
So Let over Lambda is a book that you have to take with a lot of salt.
Some pepper.
It's a very opinionated book, so you kind of have to understand. It has good underlying principles, but you kind of have to understand them through the kind of the author's. I don't even know how to say it.
His lens.
Yeah, just the author's very heavily colored opinions.
Okay.
Idiosyncrasies.
Yeah.
Okay. So what this does is it's defining a function which is specified by n, and it then goes through and applies it in this tag body, which I'm not entirely sure that this actually would work. But then again, this section here is something that I'm not entirely familiar with. So what I did was I went ahead and implemented the macro that he specified. The factorial macro example that he specified, so I could do a macro expansion here. So if we do m, it is comma mss.
Yes.
Yeah, and then we do an e. Why isn't it not expanding?
Did you compile that macro format?
Good point. I should first actually
start
sly because I just noticed that's the first thing.
Okay.
Yeah, give me a second here. I restarted my computer earlier and I forgot to. Okay, hold on.
Oh, it's probably just really annoying that you tried to compile that without having the macro also compiled.
Yeah, I just noticed that. But I'm just gonna go ahead and load my stuff. What?
Uh-oh.
Oh, jeez. Okay. Today is not a good start already. Okay. One moment.
Just load in the stuff you need from that buffer.
Yes.
You'll be fine.
That's what I'm gonna do.
If you do a selection and then do comma CR, it'll compile just that region.
Okay. I just loaded that package. Programs that program. One of the nice things about CL project versus a quick project is Fukamachi decided to make each package to be a single Lisp file. I'm still not entirely sure my feelings on that, but I'm getting used to it, and it's kind of it's kind of familiar for folks.
It plays nice with local nicknames.
Yes.
But I still am getting used to projects like that myself.
So yeah. So this actually should have loaded now. Let me just go back to Macrolet. Okay, so now I should be able to do this. Yeah, okay. Now, MS, there. It's not a macro form. It is a macro.
Revert your buffer.
Revert it.
Hit Q.
Okay.
Do space B, and I think it's R, but it might be capital R. What's the one named revert buffer? Shift R. Yeah, capital R. Yeah. Okay, now do it.
Okay.
Basically, if you open a Lisp buffer without fly already loaded and connected, Macrolet doesn't realize it should be using the fly backend, and it actually uses the Emacs Lisp backend instead.
Oh.
So it tried to expand that as if it were an Emacs Lisp macro named nletTail. I don't know why it does that, but it's a lazy initialization bug, and it gets resolved if you revert the buffer.
Okay. Okay, so this basically reinitializes the buffer like things to allow you to leverage.
Yeah.
Okay.
Yeah, reverting the buffer reloads it from file, and it also resets some stuff. It doesn't reset everything, but it resets some stuff, and it's enough to get Macrolet to do its job.
Cool. So
or
this,
macro step to do its job.
So this is the expanded version of the nlet factorial macro. And this, for folks who have actually been in our previous discussion, been reading the book, this is the exact, a similar expansion like if you used the label macro that we defined earlier in line 112. Except instead of labels, it's Macrolet. Now, question one for me is I guess obviously, what does this? I'm still not convinced that this is buying me anything compared to the labels example, and that's one question I have.
Well,
for folks
so
on the channel.
you'll notice that the call to fact in there is underlined because
Yes.
it's recognized as a macro call. Go ahead and expand that.
All right. What?
Oh, that's annoying. I can think of reasons why that would be. It's just annoying what it is.
That's something I've been running into lately. There's something about macro expand which doesn't pull the surrounding environment down.
Yeah.
And it's not a bug with macro expand. It's a bug with like the implementations macro expand.
Actually, what it looks like to me is what's going on there is something to do with the gen sims of the Macrolet. If I'm looking over at the REPL buffer.
Really?
Yeah.
Oh yeah, because it thinks it's two different symbols.
Yeah, it's not recognizing that, and so it's erroring. And when it errors, macro step goes, "Oh, well, it must not actually have been a macro or something stupid like that."
And I don't know if this is going to be like more or less confusing, but one explanation, or like a simple way to kind of think about this, is that what that macrolet is doing is it's defining a macro such that a call that looks like a recursive call is instead replaced by set the values of the variables and then just loop, just go back to and restart that whole code block.
Right, but that's what the block and tag body stuff does anyway, right?
No.
Well, no. The tag body sets up so that you can actually get back.
Yeah.
That the NN, right? That's basically the start of the function, quote unquote.
Right.
Right. So, it's got those let args. So those are your variables. So those get bound to those initial values, and then within that body, whenever you quote unquote call yourself recursively, what you're really doing is it expands out into code. That's where that piece
okay. So it re-expands it recursively again. So this is where the recursive expansion piece comes in. This macrolet. It keeps all right.
Yeah. So if we were able to successfully expand out that fact that you have highlighted right now, what that would be is it would set the value of n and ACC to those parameters that you're passing in. It's doing that psetf.
Yeah.
Right. And after it sets those values, those variables to the new values, it'll just go back to the beginning. That's where that go comes in.
Right, and that's how you're implementing the recursive call. The recursive
exactly.
Call
so it looks like a recursive call, but really it's just reset the variables and then just jump back, which is essentially what happens in a tail call optimization, to begin with.
Right.
And that's where the trouble comes in that Jay was mentioning earlier, which is that only works if 100% it's a tail call, right? Because any other if you call that function, quote unquote, call that function in a non-tail call position, the code's going to do some weird stuff because it looks like you're calling yourself recursively, but really all you're doing is resetting those bindings and then going back.
Right.
So if you call it in a non-recursive or in a non-tail position, it's just going to jump back.
Okay.
Does that make sense?
Yeah, that makes a lot more sense.
So you'll never actually do the if you have non-tail code around it, you're kind of destroying it.
It's gonna actually return.
Now,
back.
would SBCL actually perform?
Oh yeah, it should give you a warning.
Elimination and everything. So,
it should. Yeah.
Okay.
That's a good point.
I'm not sure how tag batty comes into play with SBCL's dead code elimination. So
yeah, it should be able to see. It should be able to see that it'll never execute the code after it.
The unconditional go will trigger the DCE. I'm almost certain of that. Rob, can you try something for me?
Yeah, sure. What's up?
Select the entire Macrolet expression, the generated one.
The generated one. Hold on one second. Do you want me to collapse
the one
this?
inside of a tail fact. Just select that entire expression. Starts with Macrolet.
Okay.
The whole body of the function.
All right.
Basically, select the entire macro expansion.
Do you want me to collapse this and then select this because
Not yet. Select it first and copy it.
Hold on. For some reason, it won't allow me to start from the beginning of the buffer. So I have to go all right. You want me to...
No, you go all the way up to the Macrolet.
Oh, okay.
Just type YAB on Macrolet. That'll do it.
Yeah.
Okay, YAB. Got it. All right.
Hit collapse. Or just Q. Either works. But yeah, Q. Go to there and paste it.
Okay.
There we are.
And you want to wrap this?
Remove the no, don't bother wrapping anything. I mean, you could, but don't. There's no point. Remove all of the hash colons in that area. Like, select that whole thing. Like, that whole section you just pasted in.
Sorry. Hold on.
Yep.
Percent. Okay.
And then hit :S / hash colon / Enter. Oh, you have to do it again. Sorry, I forgot because you don't have the G flag turned on by default.
The G. Oh yeah, I I was wondering where's the G? Okay, there we go.
Oh, okay. Now try hitting macro step mode, MS.
Okay.
I don't know if this will work because as Wolf was saying, macro step doesn't always keep track of enough of the local state to catch that stuff. But it's not recognizing it now. That's unfortunate. Oh no, it did.
No, it did. Look at that.
Did.
Nice. There we go. And now you can see it.
Yeah, that's what I was expecting. Okay. All right, that makes sense. So we're almost as if this Macrolet design, like for a recursive call function, it's almost as if it's just unrolling, right? Like, and it's setting everything up so you can just use a jump call to implement your tail call optimization. It's like a workaround instead of having to.
Exactly. Yep.
Okay.
It's basically manual tail call optimization.
Yeah. Okay. Cool. So one of the nice uses of Go, I wouldn't say you should use Go in a lot of other cases, but
not by hand. But I mean, what we're literally doing right now is implementing an iteration utility. Right. And when you implement an iteration utility, the way you do that is with tag body and Go.
Right.
That's what they're there for.
Yes. Yeah. That's really cool. Okay. Yeah. There you go. That's nice. Okay, that makes sense now. So the nice uses of Macrolet almost allows you to walk through the tree, and in cases where you do want to have more control over the macro expansion, you could just simply wrap a Macrolet into your desired expansion and just call it. Is that kind of like what its real use is? Like this one is kind of like certainly an example that gives us a very good use case for it. But I'm trying to say in general, like where would Macrolet
It
be really
handles
used?
a lot of cases where you would otherwise need a code walker. That's why
Okay.
you were saying that it basically is a code walker. Doesn't handle every use for a general purpose code walker, but you need a code walker if you would want to implement Macrolet yourself.
Yeah.
It's a particularly flexible case. So, but like any time you want, you're basically writing a domain-specific language that like mixes your domain-specific stuff with regular common Lisp code, and you want to set up certain sub-expressions that are evaluated specially inside your domain-specific language, even though you're intermingling common Lisp code in there. Using Macrolet is a pretty clean way of making sure that the lexical scopes line up correctly, instead of trying to manually, go in there and expand stuff. It doesn't handle every case, though. There are a lot of situations where, like, if you need to wrap something around the entire expansion based on whether or not you've stuck something deep inside of the, deep inside some common Lisp code, then you can't just use Macrolet. Then you need a full code walker. Like that's why Iterate, for example, needs a full code walker, because it lets you do silly things like, use regular common Lisp if, and then stick a collect inside of one of the branches of that, and it has to figure out the right way to introduce the variable around there where it's going to be collecting those values. And it doesn't always introduce that variable, because it can't always introduce that variable because you might name the variable something, and then so it can't just use a macrolet there, because the macrolet happens entirely after your macro is expanded.
Mm-hmm.
And so if you need to, based on whether or not your local macro gets used or your local sub-expression overriding gets used, you need to wrap something extra around the full expansion, then you can't use macrolet. But in pretty much any of the other cases where you're doing, something really domain specific-y, or something kind of complicated where you want to intermingle regular CL code with your macro code, Macrolet gives you a good way to make sure all the scopes line up.
And does Macrolet, and this is one thing I think Doug hinted in his book, but I wanted to make sure that I understood it correct. Does Macrolet handle all the edge cases for all the special operators? Or are there cases where...
Yep.
Okay.
It handles all of them.
It handles all of them.
It's defined to handle all of them.
All right. Okay.
I mean, so any actual sub-expression that starts with the name of your macro, your local macro, will get expanded using the expander defined by your macrolet. And that works for any special operator defined on your implementation.
Okay. All right. Cool.
Which is something that you can't actually guarantee with a custom code walker, because implementations are allowed to have custom special operators.
Right.
So that's a discussion for another day.
That's all right. That's we keep opening up more like tunnels through this maze that is common Lisp as I've been going through this. All right, let me go to the next topic here, which is Lambda, which is the other big thing. Now, for folks who are looking at this, you must be wondering what all these examples are. Doug went through a lot of trouble to talk about transparent specifications, which I guess I should at least mention here. I don't know necessarily when this is actually a useful thing to know, because he's like, oh, sometimes you might want to go and make more English list accessors, so you could write 20th instead of saying, car. What was it? It was like he implements ent, catter, and nth in terms of these functions here that you're seeing here, the CXR star. And what it does is it uses catter to actually go and implement the iteration to the particular pointer that you were trying to access. But I honestly don't know. I've never seen production code that leverages this kind of technique. Maybe others may have.
You probably never will see production.
You probably won't. I mean, typically, if you're accessing the 61st element in a list, you probably chose the wrong data structure.
All right. I figured that was the case, which is why I'm going to skip this particular section. The book actually does a fairly good job explaining the case. he says like there's one realistic use case, but I don't believe so because I've never seen anybody use this in production code. So I'm just going to leave you guys to read that section on recursive expansions and solutions, to be honest. And if you guys find out, if any of you who's watching or anyone here knows of a real like legitimate use case for, oh wait, we should totally write it this way in order for us to account for this, please let me know and we'll cover it, because I just cannot for the life of me figure out a good realistic example for that particular section in chapter 5. But let's go to D Lambda. D Lambda is actually kind of neat. When we talked about closures, we've kind of mentioned, and I mentioned that closures are a way of making like primitive objects. It encapsulates a lexical environment, allows you to invoke certain create functions on top of it. But sometimes you may want on a particular lexical environment, particularly the variables that defined there, allow to run different methods and call different operations on the same set of variables. So like in this example here, down here in line 311, we're defining our our classical counter example, and we may want to be able to increment the counter, decrement the counter, reset the counter based on certain situations. One way to handle that is, of course, create a case statement where, based on what is passed in, you can call the appropriate function. So certainly you could write something like this, and I'm pretty sure many of us have written something like this, where you do let, and I won't actually, oh shoot, that's why, let count 0, and then we write a case statement on the message that's being passed. Sorry, we can create a lambda with the message that is being passed, and then in here we check the message, and let's say that if it is an increment, I'm only going to write the increment and decrement sections of this. Just
don't need the parens around the expression to pass to case.
Right. Case actually has two syntax for its branches, quote unquote. You could actually dispatch on multiple values, and that's when you need the wrapping of parens around it like that. But you can just have open paren, colon, inc, and close paren.
Open.
Yeah.
Oh, okay.
Yeah, that's in case you want to dispatch on multiple values.
Oh, okay. So if I just wanted to do this, I could just say inc, like this. Is what you're saying?
Yep.
Okay, got it. So this defines a very simple counter that allows you to pass in, and I think I could also do this. Hold on, sorry. No. Undo. There. Let me do def parameter, because I hate doing setf without actually defining it. Okay. And let me put the star here. And this guy basically is going to be, if we use this, we can counter pass in.
Fun call.
Oh yeah, that's right.
Good old Lisp 2.
Test counter is unbound. What are you talking about? I just bounded it.
Not in the common Lisp package, you didn't.
Oh, that's right.
Go to your file and do --ss, or set the package.
Yeah, I could do that. I'll do that. --ss. I keep forgetting that I could do that. Okay. Now, all right. So when you call fun call on this closure and then pass in the increment function, obviously it's calling that piece of that form that to increment the counter. Instead of doing all this for all these different cases, you could just simply write, and this is what D Lambda is for, a macro that sets up that template for you. And this is a fairly complicated macro at glance, but really it actually does something pretty simple. And we will just go ahead and compile this and then be able to do a macro expansion of this guy right here. MS expand. So when you use dlambda, it will generate the lambda function for you. I'm not entirely, and this goes back to your point, Michael, about the different styles of using case. Here you can see that he leverages and only gets the first argument, and I guess what you could say is we can actually simplify this and actually just do case comma args, right? If what we're doing is passing.
Well, no. So the paren syntax there on the case so that you could have multiple options that all lead to the same branch.
Okay.
Like you could have a branch that does something for both inc and dec, and that's when you would wrap the parens around it like that. For single keywords like that, you don't need the extra set of parens because you only care about that single value.
But what about here, and this is what I was trying to get at, in line 298, you said that I didn't necessarily need in the case statement to wrap around message.
You don't ever want parens around there.
No.
But if I'm passing...
do you see how in the expansion it's two open parens and then inc?
Yeah.
Okay. That's because your macro there... that's because he's, oh, wait. Oh, yeah, he's...
Yeah, he's wrapping it in an extra list. And
line 312.
312.
Yeah. This guy right here.
Get rid of that list right there.
Okay.
Just RD, that would work.
Go to the open paren before car.
Okay, hold on 1 second. Let me just go to 312 here. Okay, so open
paren.
Yeah,
space KR.
Space...
Open paren before car.
Oh, before car. Okay.
Yep, space KR.
Space KR. Alright.
Go.
Cool. Okay, so let me compile this guy. Then... Yeah, this looks much cleaner.
Much cleaner.
Much cleaner.
Now that's the same code because you don't need multiple values for each branch there.
Right. But this is the way you would normally define an object anyway. What Lisp allows you to do is you can specify multiple keyword symbols, right, and then pass it in based on the list, and then that's using the case statement too in other languages. If you want to actually say, based on these different cases, you could just use the same branch. But
and this is the same duality of syntax for case and all its variants, as well as type case and all its variants.
Right. Well, the type case one we will shortly get to at some point, because that's something that I've been playing around with quite a bit.
No, I'm not sure that you can do that with type case because how would that play with compound?
Ignore what I just said. You're right, Elijah. I'm sorry about that.
That's again, we need. We need to, this is that type case and its family, I think, of things is something that we should discuss at some point when we start talking about the type system.
Oh, definitely.
Yeah.
Very useful.
Whenever I think I want to pull out type case, I usually just pull in trivia anyway and do proper pattern matching.
All right. So
unless I'm doing something like very mathy and very low, very high performance optimization kind of stuff, and I want to keep the dependency small. But other than that, if I'm pulling in type case, I usually decide I really want pattern matching and just pull in trivia anyway. Well,
then we need to go through trivia at some point because I never heard of that library. But to finish up this, I mean, this is a fairly simple macro in my eyes because it's just literally just expanding into a case statement based on the message that's being passed into. But not understanding dlambda, the dispatching lambda, will make some of the other cases that Doug goes through in Chapter 6 on Anaphoric macros fairly difficult to actually get through. But this is a good segue into what are Anaphoric macros. So give me just 1 second here. I'm going to open up my Anaphoric macro file. All right. Okay. Anaphoric
Can you use
Macros.
them for me?
What's up?
Can you use them for hit equals Shift G, please.
Oh, jeez. All right.
Thank you. Oh, what? What? Args out of range killed buffer? Dear God.
What are you talking about?
It errored.
Args out of
What
range.
the heck is that?
I do not know. Hold on.
Okay, just select the entire file and hit equal. Please.
Okay, select the entire file and we'll do what now? The command.
Equal sign.
Oh, the equal sign. Args.
Yeah, that's not going to work because you have. Scroll down in your buffer a little bit.
Okay.
Line. Oh, keep going. Yeah, right there, line 92. That.
Oh yeah. Okay. Sorry. I was using. This is from his section on the reader macros. Give me a second here. For some reason, reader macros always like kind of mess up my Emacs.
Yeah, they kind of do. You need to be careful about them. Anyway, yeah. Now go up to the top, and then just do equal sign Shift G.
Yeah, I know, equal Shift G, but it says still line 13. Hold on, line 13. There's something about line 13. Wait, what's wrong with line 13? It's just a freaking function.
I'm very confused right now.
I have no idea why it's complaining.
Save and revert your buffer just for the hell of it.
Okay.
Yeah.
Save and space K. No, not space.
No, space B.
Space B,
Space
yeah.
capital R.
Space
Capital
B,
R.
capital R. Yes.
Yes.
Okay.
Okay.
GG.
The other thing to note, by the way, about reverting the buffer is that if you have unsaved changes, it'll drop them.
Yeah.
So.
That's what I figured. Why I should write. I mean, that's pretty.
Yeah.
That's even standard in Vim, but Vim at least like says you're about to reload the buffer. You need to save your changes.
Well, that's why it warns you about doing a buffer revert.
Yeah.
Oh, I see. Well, I see an error, but that's. Oh, never mind. No, I don't. Never mind. I couldn't tell you. I'm very confused.
Yeah.
I'm saying line. Okay, you know what?
Hit space HDK equal sign.
HDK equal sign. Hold on, sorry. No. Quit. Space HDK equal sign.
Oh, okay. Okay.
Yeah. So that's what. I don't understand.
all right. Try this last thing here.
All right.
Capital V.
Capital V. All right.
Capital G.
Capital G.
Equals.
Index.
That's what I did.
Args out of range.
And it's referring to a killed buffer too. That's what really confuses me.
Okay, you know what? Hold on 1 second. I'm gonna reload this guy. Anaphoric. Okay. What killed buffer?
And there it is. Error.
You know what?
Buffer.
I bet you there's
Okay.
I know what the problem is. I bet you that there's some like Emacs buffer like stuck in that directory, like that didn't properly get cleaned up when I restarted my machine earlier today. And I have to just blow it away. Source, where are you? Yep. Let me do this. Okay. Still, holy crap. Okay, I'll make it. I'm gonna
Restart your Emacs.
Okay, hold on,
You are.
folks. We're having some technical difficulties. Let me restart Emacs.
That's just weird, man. I've never seen an indentation in file opening complain about a missing buffer. Something's broken.
Story of
Yeah, that's a pretty new one to me too.
story of my life. I find new problems as I do live demos. uh, my apologies. Let's see here. Source.
Okay, I think are we how many episodes in are we now?
Oh, we have a lot of episodes in. I think we're getting in on a year's worth of material here. So
yeah.
So this
is little over, like almost 50 now.
Yeah, we're in the 40s. We're in the 40s.
So 40 episodes, and we get to have to restart Emacs on stream.
Hey, that's not bad,
not
right?
Bad. Yeah.
Okay, this actually worked. Restarting Emacs actually worked. Let me just go ahead.
Oh, good.
Share my screen so I could show this to you guys, and then share it also on my on the actual. Okay, excellent. You guys can see that? Okay, cool. And let's start up. Buffer and okay. What? That's what I meant. Okay, indenting region is all done. All right. Okay. What are anaphoric macros? Now, if you're reading only let over lambda, and you're not familiar with anaphoric macros, and this is the mistake I made, I strongly encourage you to go back, download from Polygram's website a copy of On Lisp, or if not, purchase it if you could get the paper copy, and read Chapter 14 on Lisp, because in my personal opinion, I don't know what other opinions are on this discussion, Polygram does a far better job in explaining anaphoric macros than Doug does. And Doug extends his thing. Once you understand anaphoric macros, Doug's examples make a lot more sense. So I'm hoping that, with this discussion, this will give you at least a start to go through let over lambda.
I will agree with that. I think Doug makes the assumption that you've already read Polygram's book in the beginning anyway. It's just an extension to Polygram's words.
Well, he mentions it, and then he mentions what anaphoric macros are, but then he doesn't go into some of the more, like, ad nauseum examples. He just goes, go back to Graham's book. So I was like, okay, I'll go back to Graham's book. So today I'm hoping, what I did was I married some of the simpler examples from Graham's book and into this discussion, so that we could go through them, and hopefully we could get into A lambda and A let over D lambda, which is the way that he does some I forgot what it was. It was not the before and after methods. It was related to what he calls indirect chaining. I'm not entirely sure what. We'll get to that. Let's first start talk with the basics. Now, the background behind anaphoric macros is the example that that was presented in On Lisp was this pretty nice example here that I'm showing you on line 12. Sometimes you might have some crazy calculation. I'm right now just summing up a 10 million numbers, which might take a few seconds if you're running it based on your common Lisp, and you might want to be able to refer to this in other calculations later on in some code, like in this example here, which I commented out. This guy may want to, what normally people will do is they'll assign it to some result, and then they'll just access the result that's already been pre-computed. One way of actually doing this is just simply having a way of referring to, and this is ultimately what it is. You want to have a way of referring to some calculation later on without having to actually define a variable for it. So what Paul Graham did was and what the idea is we can use linguistic techniques, particularly an anaphor. And an anaphor in linguistics is basically something that refers to a previously mentioned subject. A simple example is get the wrench and put it on the table. When anybody hears that sentence, we know that it, which is a pronoun, is referring to the wrench in that sentence. It is an example of an anaphor. What Paul Graham, the idea of anaphoric macros is introducing an anaphor in a way that you can then use it in real code. Elijah, do you want to mention or expand on that, or?
No. Sorry.
I will just
Well, Philip Green's fun. Yes. Okay, go ahead, Michael.
Oh, I was just going to say that it anaphoric, technically speaking, doesn't have to refer to a previously mentioned subject. Like if you were to change that sentence to get the wrench and put it on this table, both it and this would be anaphors.
Right. But even in that, this table is an implied context, right? Like I don't think, and
how about get the wrench and put it over there?
Right. Yeah, there is clearly an anaphor, and we know based on the implied context, right? I mean, I think so, right? Yeah. Generally speaking, and this is what's brought up in chapter 14 of On Lisp, anaphoric macros doesn't cover everything. It's not going to cover the entire gambit of linguistics uses of anaphors. There's a very restricted subset of it, and it's very it's because of good reason. Like certain sentences that could be legitimate like English sentences based on, or even general sentences in other languages that uses anaphors. It could make sense in the spoken context, but in the logical context, when we're writing code, it'll be very ambiguous for a compiler or parser. So what anaphoric macros are is a very restricted but very useful subset of anaphors being used in real code that give you the ability to, in the cases that we're going to be seeing today, refer to previously computed values. Although it could be, there are other use cases if we go into other situations, but the ones that I'm going to be showing today, and the ones that are at least in the book, both Letter over Lambda and On Lisp, they're referring to basically calculations and computations and expressions that you want to refer to later once they've been evaluated. Now, the canonical example of an anaphoric macro is what he calls anaphoric if, and I have that shown here in line 20. It takes some sort of test expression in your true and false, and it all it does is it introduces the it variable to refer to that test, and then inserts it into the code. And a nice thing that this will allow you to do is this calculation that we see above here will get transformed into just simply a if some long calculation foo it. And what we're doing is it is clearly being referred to, and it's being introduced by the AIF, and it's referring to some long calculation. Now, you might be thinking, wait a second, this looks like unwanted capture that we've seen earlier that we wanted to actually get rid of. We thought that was a bad thing, which is why we introduced, using gensins to actually get rid of unwanted captures. This is one use case where unwanted capture is useful, if not desired, to simplify code and allow you to make new forms. Michael, Elijah, or other people who have thoughts on this, is there anything that I should add to that?
Not really.
But I was just wondering, does anybody have any thoughts on, or is there any talk in the community anywhere about this kind of leaky abstraction causing other problems, or?
Oh yeah.
Oh, definitely.
A lot of people who talk in the community about how anaphoric macros are really leaky abstractions and really ugly as macros. It's why I use len let instead of AF.
I'm pretty sure like 90% of the community leans against using anaphoric macros.
Yeah. They're neat in some cases, but in the general case, when let is not much worse than if, and it is actually even more flexible. So I use when let instead, or
And-
if let, but you know.
Is nlet defined in some library already?
When let, it's
Yeah.
in Alexandria.
It's in Alexandria. Okay, got it.
But it does come in useful in certain situations where it makes a lot of sense to use them. And unlike certain other dialects of Lisp, we aren't restricted from doing that.
Yep.
One of the
Well,
interesting.
Racket.
Assuming that's like this is how like Loop does a lot of its magic, right? Because there's lots of kind of keywords in there that are referring to the things that you're some of the parts of the looping construct, and so I'm assuming that that's how like a lot of that stuff is actually implemented.
Yes.
Yeah. When you're doing things like in loop, how you can say when blah collect it as like a bit of loop code.
You could do like summit like this, and I think this,
No, that will not work.
wouldn't it?
That will sum a bool.
Oh, all
The
right.
it is the thing that was tested, or the result of the test.
Oh, okay, got it.
But it's useful when you have things that might be null.
So I could do this though, right?
Yes,
It'll
it'll just sum all of them anyway, because
Right.
I is always true.
Right. This is never. This is a dumb example, but it also shows that you can do it. I'm just.
Right. Yeah. It shows what's actually going on there.
it and I think if we let me just compile this and see if I can actually can I expand this? No, I cannot expand this.
Revert your buffer. We're having that same issue from earlier.
Ah, jeez. All right. Quit. Space K. R.
Nope. Space B.
Oh, dang it. Space
You'll
B, R.
learn them all. It takes a little while.
Ah, jeez. Eventually, at some point.
So one little caveat though with the loop it is that it's not
It doesn't actually.
it's not really introducing a variable
Yeah.
so much as it's introducing it's part of the loop context where it's not really a variable. That's why I don't use it in loops very often, but when I do, I explicitly put it as a keyword because just to remind me, it is not an actual variable.
Yep. It is not a variable.
That has consequences if you're trying to use it in a sub-expression. So, for
Right.
example, you can't do say you do like when I, you can't do like some plus, 1 plus I or something like that.
Okay.
Or 1 plus it, rather.
Yeah. 1 plus it.
So, let's see, where did it...
Oh, yeah.
It got replaced with a.
Yeah, I got it
Loop it.
replaced with loop it. Loop it 734. That's what it is.
Yep.
There you go.
So you never get to actually see that variable as a variable.
Right. But
Yeah.
that makes sense. I mean, it will be a something at some point. Someone will generate that and then...
Well, if it were actually an anaphor, then it would actually be a regular variable, and it would keep the name.
right.
Well,
Well, it is an anaphor in the general term, but it's not an anaphor in the same way that the AIF and the other conventional anaphoric macros work.
So if I put this, will
That'll
this
still
work? Okay.
Yeah, that's what I always do because again, you can't use it in a sub-expression. You can only use it in a loop context.
Got it. Okay.
Yeah, it's part of the loop language.
You're right. It and this, there's a couple of keywords. They almost always end up being. They were suggested that they're already like keyword symbols for it. I think it was actually mentioned in Letter for Lambda for some reason, but I don't remember as to why. But what you're telling me is loop doesn't leak it's still
Exactly.
generating a gen sim behind the scenes for its anaphors, and it closes
Exactly.
it.
Yeah, it's not leaky.
Yeah, it's not leaky at all.
I mean, it's a little leaky if you happen to be using it as a regular symbol, but you can always just use the keyword version, and it's unlikely you are binding that keyword locally.
I don't think is that legal?
It's not. You can flet a keyword though.
Oh yeah.
Fun fact.
Yeah.
You know what's really terrible? You can defun a keyword too, and def macro a keyword.
Oh, jeez.
Yeah, and actually,
I'm guilty of that.
No.
I have that in my core image for printing a hash table readably.
There's a library, rutil, if I remember correctly, which one of its standard things is it aliases :equals to p set f, right? And what that does,
Oh, I see.
screws up the indentation of the equals form.
Oh, jeez.
Yeah.
Oh, man.
Yeah, anyway.
That
That's the only reason I know that you can do that. That you can change the function, the simple function binding of a keyword without breaking stuff.
Interesting. So, I thought I'd go through some simple examples of going. Obviously, these are all straight from Graham's book, but they really show how you can compose these guys above. But at the end, they're still all using the same anaphor. So like a when is technically a if, that uses the test form of the prog end body. This is actually still using it, has the anaphor behind the scenes, and it's still captured. It's still an unwanted captured symbol that you may later on pay a price if you're not too careful. Later on in Letter over Lambda, by the way, he goes through some cases where you're like, you can introduce an anaphor and then close it, and then you'll be fine. Which I guess, based on our discussion, is what essentially Loop did. It had introduced an anaphor, and then behind the scenes it closed it so that it doesn't leak out. So using anaphors in your code, and even defining anaphoric macros, doesn't mean you need to define a very leaky abstraction. But if you define it the way some of the examples have shown you to define it as, you will leak your variables out. And that could have consequences depending upon how complicated your code is and how it's referencing other code that may have introduced the same anaphor in their code when they're expanding their own macros. So anaphors can be defined in a lot of places. We're just going to go through some of these examples here, like a and. This is an example of using a and that I just defined a simple, if your owner, an address in town, and we could see that this actually recursively defines it until it ends up, completely expanding out the entire tree. So if we end up calling this guy, hopefully, let me do this. I don't need this guy anymore. Give me a second. It said space KR, right? Yes. That's what I wanted to do. Okay. We expand this guy out. No, sorry. Well, you'll see that a and will expand to a when, and it will keep allowing you to expand out until it will hit to some null case here. And of course, a when is its own macro, which calls a if, which let me go ahead and do this. Compile this guy, and then we'll be able to actually expand this guy. We'll see that when we call a if, it'll just go ahead and create the actual let and create the anaphor it, and then allow you to call through the code to actually reference that specific calculation. So all these are just simple examples. This code is actually checked in the Atlanta FP repository. I will post on the YouTube channel the location of this so that you guys can check it out and play around with it. But on top of this, there's two other examples that, what's it? And I'm going to ignore A block and A lambda for a minute just because of the fact that we'll be going through that in just a few minutes here. But I wanted to start with this additional thing, which is the use of anaphoric macros is not limited just to normal macros where you're taking a Lisp form and expanding it to Lisp form. You can actually use it across the board. You could define reader macros that have anaphors in it, and these are what the book calls read anaphora. So in this example here, we define a anaphoric macro that would what was it? It was getting the characters from that are being passed in here in this reader macro, and it just simply creates a let expression for them. And the use case for this particular reader macro is if you're trying to define, let's say, a huge let block, and you have 1,000 like a lot of different variables. I wouldn't say 1,000, but a lot of variables that you want to put in this let scope. You can create this reader macro to make it a more convenient way of defining those variables. And if you're especially assigning them all to the same value, this will do it for you. So if we go through this, and I don't believe I need to convince you that this will actually do its thing, but we'll go through it anyway. Last time I did reader macros, we had some fun, if the folks here recall. So hopefully this time I won't have the same mistake. Oh crap! Hold on 1 second. I have to define make stir and sim. Now, I know Michael, you mentioned that that Alexandria has symbolicate. Unfortunately,
yes.
When I tried using symbolicate on this example from let over lambda, it did not work. So that's something that I'm hoping that today we can go through, or if not, later on. Either way.
Yeah, we can see which one if you want to try.
Yeah, but I'll first show. Let's see if I can do this macro expansion here.
I don't think you can expand reader macros.
Yeah, you cannot expand reader macros, so I'm going to have to go and grab this guy. What is it? V $sign. Let me see if I can run this. So when we actually run this A1, you noticed what it is essentially just expanding into is nothing more than a lambda function that macro expands and uses that previous value inside its inside the actual code. That's all this particular example does. But it's useful if you're defining, say, a bunch of variables. So like if you see here, this example here, and this is ultimately what it was leveraging. Yes, let me see if I can copy this and paste this. This, all it does is taking a list of variables and it's defining all those variables in a let block with the same value. If I remember, yeah. So, no, it did not. Hold on 1 second. No, it defines them with a new gensim. That's what it was doing. So if you're creating like a macro that requires a bunch of gensims that you want to relay, define has different variables, you can use this to define your own variables, get the gensims, and then reference those guys inside a more complicated macro. Now this is just a trick. It's a nice convenient way of doing this kind of stuff so that later on in your macro code you don't have to do a lot of work. but he brought it up saying that, oh, this is just another example of doing like read anaphora. Are there questions about this one? Because this is a fairly straightforward example, I think. Silence. All right. Okay.
Yeah, I'm trying to. I don't know that that's the intended usage of this. That is to say, like, just define a bunch of variables. Because if you see, like, the usage of that particular syntax and the fact that it returns a lambda, to me indicates more that it's trying to create an inline function analog, because the body of the quote unquote body in there is going to be the body of the lambda. Right? So it's a way of defining a function in a single line like that very quickly, that has the variables implicitly, or not implicitly, but implicitly via anaphora bound to A1 through however many variables you requested. Right? So it's a way to write an inline lambda easier.
Yeah, you might want to check out Serapium's op operator. Which
Serapium's op macro
thing, except without the ugly syntax.
My answer to that.
So
Yeah.
I got this use case straight out of the book.
Yeah.
It says,
Well, how it's being used in that particular loop, right? So what that loop is doing, or if you look at like what that the reader in there in that loop is doing, it's creating a function, right? The #2 backtick. It's creating a function that will return a list containing the two arguments that were passed into it.
Oh, right. Okay. I see what you're saying. Right.
Yeah.
Right.
So there's kind of multiple levels there, but yeah. So it's not that it itself like creates those variables. It's just that. Yeah. Exactly. There you go.
Yeah, I see what you're saying. You're saying that this guy. Okay. The common.
So the use of the. So right, in that context, it's being used to create those variables. But the reader macro itself, the purpose of it is to define
an inline function that you could then reference later on.
Yeah, an inline function that has that like back quote syntax, for defining like a list structure.
So this is allowing you to essentially create functions that you could, through a macro expansion, that you could then leverage through mapcar, is what you're... Okay.
I mean, maybe it's helpful to just copy paste that code and write the equivalent code, just so you can see like what it's trying to do. Because that #2. Oh yeah, if you want to. Copy.
Mapcar. You're talking about this guy here.
I mean, you can just cut. Yeah, that should be fine.
The percent, sorry.
Yeah, no worries.
Okay.
Okay, so get rid of the #2.
And
whatever,
then
and then
lambda.
create a lambda. Takes in two arguments, A1 and A2, and it returns backtick, open parens, comma A1 and comma A2.
Okay. Let's see this guy.
See what I mean there?
Yeah, I see what you mean there.
Yeah, so it's a way to create a lambda that, because it's a common pattern, right? That you do that sort of thing. So that's.
Oops.
Oh, you need the letter around
that's
it.
right. That's what I figured. I just realized. There we go. That's right. Okay. Yeah. That makes sense.
Yeah. So that reader macro is just a way to define a lambda in which it's back quoted. It's a very kind of I think it's a very niche.
Ugly.
Yeah.
If you want to quick load Serapium, I can show you how the op.
Oh, I have Serapium, and I think I do at least.
It basically does the same thing. It's just a little cleaner syntax than that, and a little shorter than the Lambda.
Okay, so let's go ahead and create the Serapium equivalent. Expansion. Folks who are wondering if I'll check this in, I will go ahead after this discussion today. I will check this into the Atlanta repository, so don't worry.
Oh, if you're gonna check it in, make sure to wrap it up in that let.
Okay, that's a good idea.
Yeah, and then that way this code actually loads up cleanly.
And let's start this one, Serapium example. Example of above code with op. Okay. Man. Okay. So I'm going to start with, again, our same test example here, which is our list of stuff. And now I do a map car. And you said it's sop like this?
Yep.
Yep. And then you can do a back quote, open paren, comma, _1.
That?
Yep. Just like that.
You actually don't need to provide the numbers. You can just do underscore twice.
Really? Oh, cool.
Yep.
Yes.
Okay.
Yep.
So this is...
It'll number them left.
That's only if you want to go out of order.
All right.
Yeah, you only need the numbers if you need to refer to the args out of order.
Oh, okay. I will go ahead and use this one, and then I'm going to try the other example too as well once. Yeah. Okay. And now I just need to do the loop, which is just... Hold on 1 second. For some reason, I keep pressing the wrong... Okay. Bars. Okay. There's something that I'm missing. Package S does not exist. What? I've referenced...
You haven't actually been doing any of this in the package of that buffer.
I thought I did. Okay, hold on.
Yeah, compile that whole thing.
Alright.
Yeah.
Now it's all done. Alright. Let's go back to what I was looking at earlier. Let's see. What? Yeah, I know it's not defined. Jeez. Okay. Alright, this actually will load. So. Okay, so this works too. So let's see. You said that if I use the same thing, but without
just
this,
remove the 1 and the 2. Yeah, this should work.
this should also work. How does it know the ordering then in that case?
Left to right.
Position.
Oh, just left. Okay, so it's positional arguments. Okay. Okay. Cool.
Yep.
This leverages.
And unlike reader macros, it doesn't absolutely destroy not only your file, but the eyes of anyone reading it. that's the worst part about reader macros is the fact that the editor doesn't know how to handle them, right?
Right.
It's all sorts of trouble. I'm a firm believer that 999% of the time you shouldn't use a reader macro.
You shouldn't.
I will definitely agree with that.
You should not use a reader macro.
No.
Even the ones that are in the standard, I've been like, I read a recent post recently. Somebody was talking about basically just eliminate reader macros, even the ones that are built in, and just replace them by regular macros, because you can still have quote, be convenient the same number of characters by just having the quote be a macro that you can call from that first position.
But if you're making your own, if you're closing off your application, right? But you want to give them some sort of extensibility, wouldn't the only way to give them
I don't
essentially
think
an input would be
I
a
don't think
reader?
that's the right way. I don't. That's not how I would do it. The way that I would do it would be to like write my own interpreter or something like that. I wouldn't. I don't like leveraging the reader. I feel like too much can go wrong. But this is I don't mean to take it off on a tangent.
But since we're talking about anaphora and reader anaphora, I bring it up only because a couple of weeks ago when we were talking about reader macros, I brought up that, well, if you're defining your own interpreter and you want to replace the reader with your interpreter, sort of to harden, sort of so to speak, your Lisp image to prevent people from actually using the CL namespace, I think it was Elijah that says, like, well, you just do set macro character and then specify your own reader.
Well, you can do that, but I mean, the much better thing is to just not use the regular reader at all.
Exactly. And even and Let Over Lambda has what it claims to be like a safe reader, but that has so many like little edge cases. You save yourself. You end up saving yourself a lot of trouble just defining your own reader / language rather than using the built-in one and then trying to cover all the edge cases.
Oh, but that's what I'm saying. I'm like, you're building your own reader, but you're still technically leveraging the reader macro infrastructure, right? You're setting by replacing it, right?
Yeah, it just ends up being too big of a headache. There are things that are too baked into how the regular reader works that you can't override, and you kind of want to be able to override them.
One example is packages. Like, right. the package syntax is baked into the reader.
Okay.
Yeah, so, this is a whole, I think, a whole discussion in and of itself.
Yeah.
And not only that, but we need to also make it clear, what the target application is. Just certainly. So that we're all on the same exact page.
But that is, I guess, okay. So I'm just going to close this by making a comment that something that we should discuss as a group really ought to be, because this is a really big thing, hardening your, preparing your Lisp application for production, this is something I've been thinking about, and one of the main things that, I would think that you want to do before you put your Lisp application to production is figure out a way to make sure people can't just write random Lisp forms into your image, or even leverage the Lisp reader at some point.
They wouldn't be able to unless you're calling read or eval somewhere.
Yeah, if you're using...
Don't call read or eval.
Yep. Exactly. Just don't. CL read or CL eval should not be used by untrusted sources at all.
Likewise
there's no hacks around it.
Right, but this is like a huge discussion. This is like a set of things that we just should not do that I think needs to be brought up. But
never coerce to function too. That's a terrible idea.
Okay, so yeah, all right, we we are definitely going off in left field.
This is one that actually I feel like most experienced Lispers don't even know about. But did you know that if you have a Lambda expression as just the raw S expression, the list form, right? And you pass that to coerce, and the coercion that you're making is to function. Do you know what it does? It evaluates the Lambda.
Can you say that again, please?
Do this in the REPL for me, Ram.
Okay.
You may not appreciate this on the spot, but I think Michael and Wilf will freak out if they didn't already know this was a thing.
I didn't, and I'm already freaked out.
I didn't hear it really. You're kind of low, so that's why I wanted you to repeat it. It sounded interesting.
Yep. Open paren.
Okay.
Coerce. Quote. Lambda. X. As an arg. Just X plus 1.
Okay.
And then the type that you're passing to coerce is quote function. And hit enter. Yeah, that just works.
Huh.
Yeah, I had no idea.
That list dynamically.
That's crazy.
So yeah,
coerce can call eval.
That is insane.
don't call read, don't call eval,
Don't call
don't
coerce.
call compile unless you're smart,
Don't
call coerce with function.
Okay, this needs to be written. I need to write this down as so that I can repeat this later.
and of course also load and compile file. Like that should be obvious.
You can't just blacklist certain symbols though. I mean,
No, yeah.
reader macros like the float suffix, exponent suffix that could overflow or whatever.
Don't call read. Don't call eval. Don't call coerce. Don't call compile file unless you're smart.
In general, it's fine. Just don't coerce the function.
Yeah, that's the one dangerous case. It seems like.
Don't coerce a function. Yeah. All right. This is gold. But this is obviously way off in left field from what we're discussing today. But
Yeah.
I wanted to at least bring it up because with readers and reader anaphora and reader macros and Will's comment about just don't use them. Well shit. You have to write your own interpreter. What do you do to set it up so that you're only using your own interpreter and everything else is kind of like okay, so different discussion.
Yeah,
we're just gonna.
Well, you gotta ask yourself, what are you buying by using that #2 backquote ugly nonsense over like something like or even a lambda? That's not too much extra stuff to write, or SOP like you did in the third example there. What are you actually gaining by using that reader macro? Absolutely nothing but confusion and errors.
That's true. That's absolutely, and it's and I wouldn't have never thought of. I'll be honest with you, until I read this book, that you would end up using the reader macro like this, and I'm like, this looks so ugly. I won't even begin to tell you. But then there are cases where the reader macro makes some sense, like in CLPPCRE. If you want a shorthand while you're working in your REPL, where you want to be able to write in a regular expression, like those cases are controlled cases. I'm not saying that it's in every case that it's useful. There are a small fraction of cases where it's definitely useful. That's all I'm saying.
Very small.
Yeah, but it's a very small. Yes, it's
much like anaphors themselves.
Right, very much like anaphors. Anaphors. Here's the thing, though. Anaphors is not bad if you close them, right? I mean, you could still have it within a form, and your macro expands, and as long as you properly close your damn macro correctly.
And that's what Doug gets into with. That's kind of sort of how Pandoric macros work, because they're implemented in terms of some symbol macros.
Right.
In an enclosed environment.
So that brings us to ALET actually, and then even ultimately closing macros, closing anaphors, because that's a very important thing to at least know about. So in this example, what is ALET? ALET is basically nothing more. It's a anaphoric macro that, according to the book, he defines as it's useful when we have initialization code in a lambda form we don't want to duplicate. Because it is bound to the lambda form where we are returning, we can execute it before returning it from the enclosing let. So the example that he leverages with ALET is this ALET over D lambda, which is what we were talking about earlier, the dispatching lambda for creating multiple functions. In this example here, what he does is he avoids duplicating the reset and initialization code when he's trying to essentially. Hold on one second. I just noticed that he used psetq again here.
That is actually the one function in the book I didn't understand his reasoning for. Maybe it's just, I don't know. Maybe just one of his very opinionated uses, but I just didn't understand the benefits.
The benefits of using ALET percent? Or
yeah.
Okay. He's collecting like previous computed values, like the summation. So like in the reset, he's creating some initial values for sum, multiple, and exponent, and then later on he leverages it when we're calling this particular d lambda on computing, what was it? Computing the initial value sum and square of a particular set of what does he call it? A set of.
May I step in for just a moment?
Yeah, sure.
Personally, I feel like A-let is a really terribly named macro.
All right. What would you like to call it?
I don't know if I can come up with a better name for it, because I feel like what it's really doing is it's combining regular let with an entirely separate concept I think I'm going to name aprog-n.
All right.
Because that's what it's doing, right? The anaphor isn't of any of the stuff isn't of any of the variables. It's entirely to do with the code body, right? Like the anaphor there is all about the code body. It's all about the block of code. It's really anaphoric prog-n.
Well, the reason it's called A-let is because it stands as a kind of contrast to N-let, which is the named let.
Right.
True.
So the A-let, I agree with you. It's a terrible name. It confuses me every time I read it. But the reasoning is that the anaphor is for the quote unquote let itself, like you said, the code body itself.
Well, it's for the last expression. It's for the return value.
Yes, that's the main thing. It computes everything, and then it does prog-n, essentially, and then at the end it returns the last evaluated expression.
Oh, yeah. No, that's terrible. Never mind.
Yeah, it pulls out the last expression, evaluates it first, stores it in a variable, does the other expression, and then returns this thingy.
Yeah, never mind. That's awful.
Can
I was thinking that it was the equivalent of nlet self. You know what I mean?
Yeah, no.
But I need to brush up again on that code.
It's not anaphoric nlet. That would make sense.
Yeah,
I need to work on that code again.
It makes sense as anaphoric nlet.
Yep.
But no.
Michael, you said that you had a comment that you wanted to bring up.
I wanted to. There's something that really bothers me about d lambda.
Okay.
And I know it's gonna be involved if we try to do it. So probably next stream or
no, we could totally go through it. Let's.
It might be a little. Elijah would definitely need the help here because I tried to do it and
let's first talk about what is the problem, and then let's see how we.
Line 155.
Okay.
Can we modify this macro so that it's indented properly?
Oh, geez.
Oh.
Yeah, it's pretty involved.
It's not that.
I tried to do it and I failed. Maybe I'm missing something, or maybe it can be done easier, but it really bothers me, and I try not to use it.
Line 155, really? This one?
Yeah, I wish that was indented, like, a regular function.
Writing that, okay, given like half an hour, not even half an hour, given like 15 minutes of time with my actual dev environment and looking up what the indentation scheme is.
Oh, you want to write trivial indent?
Right.
No. I want to write it in terms of like and body, so it actually indents properly. You can't, is what I'm saying.
Right.
You need to define indentation rules for that.
Yeah, the only way to solve that is to do a trivial indentation hit.
Yeah.
Right.
Okay, fair enough. That's what I thought.
Yeah, and I actually have an example of doing just that because I was doing stuff for my comm stuff, and the methods are declared like in the exact style that you're talking about. So I actually have a rule for that.
You have that rule already?
Yeah. I mean, the structure is going to be slightly different, but yeah, it's not too hard to write actually.
Yeah, I just don't remember them offhand because I only write them like.
Yeah, it's one of those things you just sort of have to like play around with for a while. And
how are you guys writing indent? Are you writing an Emacs Lisp, or are you writing?
Yeah, but the thing about writing indentation rules is Slime and Sly only care about the symbol, not the package.
Oh.
Yeah, exactly. That's a bug or not a bug, but it's a feature request.
So I try to resort away from that if possible, but in this
I I don't, unless
writing indentation rules is no different than the indentation hints it learns from a macro itself.
So I'll post it on Discord, I guess.
You could certainly put it on Discord, and I'll take a look at it. I have Discord open actually. I could pop it into my buffer too.
Okay, I'll show you like what the rule
should
is,
we use the live
and then
streaming
what
channel?
it like leads to.
Hey, could you post it in the live streaming channel, I guess, rather than
sure.
Common Lisp, so we don't pollute Common Lisp with.
Yeah, that makes sense. So that's the indentation rule, and that's the usage of it. So you'll see that I have, or if
Wait,
you do pull it up.
The first line is in the indentation rule?
Yes.
Interesting.
So what that's doing is you see the interface, and it's got the thing, and then the query interface, add ref, and release, those are the quote-unquote methods. So you see I've got like the method name, and then that's for the nil is for the flags, then the return type, and then the args. So you see like it indents pretty nicely like that.
Okay,
yeah.
So for folks who are looking at this, I'm just going to post these guys in my Emacs buffer so that we can go through it a little bit. Just give me a second here.
Yeah, that's right. There we are.
And then this is the example that he gave, which, by the way, I'm impressed that you are doing quite a bit of Win32 programming.
I think that's all he does.
Because I don't. That's insane. That is insane.
As a point though, like I don't see any particular issue with writing indentation hints versus just writing macros in the first place, because the indentation rule it infers from the macro is just as non-package local as an indentation hint you supply yourself.
I feel like I want to ship my macro code, and then I want to ship an editor plugin that defines
if
separately.
You solve that separates out the indentation hints as completely in a module, that'd be great.
If the tooling were there, that's how I would do it. But for right now, you know what I'm doing? I'm doing this.
Okay, hold on one second. Let me post this.
Sorry.
No, that's fine. Just give me a second here. And he is...
Just so that I don't have the dependency on trivial indent.
Oh, nice. Okay.
It's barf. And I want to come up with like a better way to be able to and I know Shinmera is also coming up with his own thing for trying to conditionally execute code based on like the available packages, or based on the available everything. The problem is in Emacs Lisp it's very easy just because you don't have to deal with packages, but in Common Lisp it's much more difficult to kind of have like execute this code when this thing is available.
You bring up a question that I have, which is regarding the dev environment stuff, just because it seems to me that we're extending the dev environment quite a bit. Is it possible? Okay, this is my dream. I think I've mentioned this before, but I'm gonna say it again. I think we need to bring back some sort of ability to create a dev environment that kind of handles all these rules for us, so that's kind of easy to use. But
I agree.
This is the IDE dream that I think you and I kind of like talked about before in the past. That hasn't happened yet, but because I have no way of starting, I have no idea on how to begin.
Well, there's multiple levels to it, because you have the actual, and this is so off tangent. I think, from the actual conversation. So please feel free to just stop it at any time. But yeah, there's multiple levels. You have the IDE itself. You have the tooling. Because if I had a way to, like, say, hey, when you quick load this package, go ahead and also load this, like, editor plugin, right? Like, which just loads an EL file that just has, sets the indentation rule on sly and slime. That's where I want to define it. But that's completely separate from the IDE, right? That's just a part of the tooling and the environment, just like you have Quick Lisp being as part of the tooling.
Right. Absolutely.
Or another great example is, hey, when you install CL SDL2, here's those DLLs as well. You know what I mean? Or here's some rules to like get those things into your environment, so that that's a kind of one-stop shop. But that's in the tooling, which I think should be relatively divorced from the IDE.
Interesting. You're implementing the tooling first, and then you're essentially writing the dev environment on top of the tooling.
Well, you kind of have to.
Yeah.
Right.
No, that's fine. You can also make them as submodules as you load up. You can have a framework like kind of like what NetBeans or IntelliJ does. Which is a skeleton of the hooks that you need to provide, and then your tooling essentially hooks into those specific hooks, and then you have a way of writing an extension. And in fact, I was thinking like for a closer end goal, just to start out with, either start with like NetBeans or IntelliJ's plugin framework, make my way through like kind of like what Cusp tried to do back in the day with Eclipse, and create the same kind of IDE environment. But that was a big pain in the butt anyway to do.
I think the first problem that we really need to solve if we want to go down that road is we need to take a lot of the knowledge that's kind of baked into things like Slime and Sly and actually make that into separate stuff that can be used as independent tooling.
Yeah, that's probably a good starting point, actually. I never thought about that.
One excellent example is which Shinmero is doing a lot in this area. Yeah. Like a lot. An excellent example is, and it's crazy that this doesn't exist already in the standard or like elsewhere, is his definitions library, which allows you to define a definition such that you can get, for example, like go to definition, say that I create my own kind of DSL construct. Actually, this is an excellent example, those COM interfaces, right? I want to make it so that when you press like go to definition on IUnknown, I want it to jump to the defined COM interface.
Okay.
Currently, the go to definition only works for like, go to a function, go to a class, all the standard definitions. But if I have my own new language construct, I want to be able to define, hey, this is a definition, so that then the tooling can pick up on that and be like, right. IUnknown, there's a COM interface for that. And it's defined in this file.
I think what you're asking for is the ability to extend the define so that GoToDefinition knows about any new ways of defining stuff.
And that's 100% what that definitions library does. It actually works very well. So
that would allow you to do exactly what you just said. Right now, as it stands, the library, that would allow you to jump to definition at IUnknown and go right to the define COM interface.
I haven't looked into it. Like
that would I was wanting to do that with some of my DSLs for a while.
Yeah. So it's like on my to-do list to look into if Sly already that definitions library already hooks into Sly. But even if it doesn't, it would be, Like I want to use the definition libraries so that when it does hook into Sly and Slime, it will do that. It's fully capable of.
So I'm writing a note about
that meta information for that. So then later on, Sly and Slime, if it doesn't already, I don't know if it doesn't.
Huh.
So I think we should talk about the definitions library and some of these other cooler things.
That's a project I'm really excited about.
Yeah, we should probably have a month or so where we just go through like one library a week, trivia, like you were saying, and definitions, and
I'm
quick
happy
little
to
talks
do
about
more
each library.
spotlights. I like library spotlights.
Yeah, library spotlights is definitely something we should continue to do.
I had a real fun time when Elijah did his stream on what was it, Screamer?
Yeah, Screamer. That was a fun one. So we're closing up here because there are indirect chains, but really indirect chains it's just yet another extension of the same anaphoric stuff that we're looking at right now. But it gives you the ability to like look at before, around, and after, but you don't need to actually use CLOS. So he wrote functions that allow you to do that. I will go ahead and postpone this when we start talking about Pandoric, just because of the fact that it leaves a nice introduction into P Lambda too, because it goes into closure anaphoric closuring. But before I end today's discussion, I want to make an announcement to those of you, and Elijah, you already know this because I talked to you about this. We're going to take a small break from Let Over Lambda to do a series on concurrency. I've talked to you about this already. For the next, I don't know how many weeks it's going to take, but it's going to definitely be a very, I hope to be a very enthralling discussion. This is essentially something apparently you want to at least talk a little bit about like what you'll be discussing.
Sure. I can talk about that for a bit.
Yeah.
Yeah. So I'm going to be starting off with just Bordeaux threads, which is sort of the standard, threading interface, and probably going into a bit of Shinmera's atomics library, just so that we can cover those two bases, the threading side and the concurrency primitive side. And then I'll probably go into stuff like L Parallel, which is a much higher level API for doing multi-threading, with a thread pool and kind of worker queue stuff. And I might also go into a library called CL Async, which is a heavily event-driven library built around libuv. So it's good for very like high performance concurrency kind of stuff that's single-threaded, but it still benefits from a lot of that kind of event-driven concurrency nonsense, and just that kind of space. But yeah, at the very least, I'll start off with as I said, Bordeaux threads and atomics is where it's gonna begin, and L parallel probably next.
Bordeaux threads is something that I've been playing around with. As you know, I think we've actually done a couple of discussions on that. I'm excited to see how it hooks into atomics, especially because if they can play around with each other, that would be pretty useful.
They're kind of orthogonal, really.
Oh, great.
You kind of use, you can use both of them, or use one, or use the other. They aren't,
Oh,
sometimes
excellent.
you need them.
Excellent.
Both.
So, watch out for next week. We're going to be starting our concurrency and Lisp series. I think it's going to be a fun time for the next couple of weeks. And then we'll step back into hopefully more discussion on Pandoric macros and then Lisp efficiency in general, according to at least Let Over Lambda's opinion on Lisp efficiency. So,
Pandoric macros.
and
spell a name like that, you can take Doug seriously.
right. But I'm just saying, we need to at least get into the last discussion, which I'm really excited about, which is like chapter 7 and 8, which is on building fourth and Lisp and fourth and actually seeing it go all the way through. That's the real big case study that I'm excited for us to go through. But first, concurrency and Lisp. So I'll see you guys next week. Thanks for joining. It was a great discussion today. So I hope to see you guys next week. Thanks.
All right, bye.
See ya.